Today we are going to continue with partial derivatives in calculus. So this happens when we have a function of more than one variable, maybe f of xy or f of x, y, z, or more than three variables. But for now, I'm going to start with two variables. The partial derivative of f of x naught, y naught at with respect to x is, so I'm finding the partial derivative at a point, not arbitrarily, at a point. So you can find it arbitrarily, then you fix the point. Limit as h goes to 0, f of x naught plus h comma y. So the h is on what you are differentiating with respect to. Y naught minus f of x naught comma y naught all over h. So if I was to do the partial derivative at x naught y naught with respect to y, it's similar. I'll take limit as h goes to 0. Now, instead of the plus h to be on the x naught, it's going to be on the y naught because we are differentiating with respect to y. So we have f of x naught, comma, y naught plus h minus f of x naught, y naught all over h. As simple as that. So what we're going to do now, we're going to take exercises trying to get partial derivatives. So you can imagine what would happen if you had three variables. If you had partial derivative with respect to x of x naught, y naught, z naught, it will give us limit as h goes to 0, f of x naught plus h, because we are differentiating with respect to x naught, comma, y naught, comma, z naught, right? Minus f of x naught, y naught, z naught, all over h. So you can try to compute with respect to y and then with respect to z by yourself. You know that the plus h will now move to here for with respect to y. The plus h will move to here for with respect to z. So try to write it out yourself. So now let's try these examples. First of all, we are going to check for partial f by partial x and then partial f by partial y, which of these functions at this, and then this one at arbitrary point. So you don't need, we aren't given a point. We'll see how to solve that. We'll see if we differentiate normally with respect to one variable and plug in the point, if it will affect our answer. Let's just see it together so you understand what I'm saying. Solution. Partial f of 4 minus 5 with respect to x is, I'm going to just plug in my values. Limit as h goes to 0, f of x is 4, x naught is 4, so 4 plus h, comma, 5, there is no z, so I stop there, minus f of 4, sorry, minus 5, comma, minus 5, all over h. What is f of 4 plus h minus, comma, minus 5? I'm going to plug it here. Anywhere I see x, I'm going to put 4 plus h. So I have 4 plus h squared plus y. What is y? Minus 5 minus 1
6
minus 4 squared. I'm putting 4 here. Minus 5 because y is minus 5. Minus 1 all over h. So this is, I'm not sure whether the limit exists, so let me finish up before putting back the limit. So this is equal to 4 squared, which is 16. 4 squared, which is 16, plus
8
8h
plus
plus h squared minus 6 minus into brackets 4 squared is 16 minus 6 all over h. So this will give me 16 plus 8h plus h squared minus 6 minus 16 plus 6. So minus 6 will cancel plus 6 will go out, they become 0, and then we are left with this all over h. If I divide through by h, I have 8 plus h. So I'm going to take this up here now. I have this is limit as h goes to 0 of 8 plus h, and this is 8. What happens if I differentiate this first with respect to x? Partially, normal, the way we know how to differentiate normal partial derivative, and then plug in the values. Let's see. Partial f by partial x is equals to, this is what we are differentiating, 2x
plus y.
That's all.
Oh, we don't need to add y is taken as a constant.
The reason why we don't have 2x plus y, we are differentiating with respect to x. So y is seen as a constant. So we are going to take it as x comma y is equal to 4 comma minus 5. So x is 4 and this is 8.
Yes.
We see that they are equal.
Yes.
Now let's do the same. Let's get the partial derivative with respect to y. Partial f by partial y of 4 comma minus 5 is limit as h goes to 0 of f of 4 comma minus 5 plus h.
Oh, you want to go this way?
Minus f of 4 comma minus 5 all over. This is the definition they gave us. We just wanted to check if it happens the same way. Over h is equal to. So we need to evaluate this without the limit first because we are not sure whether the limit exists. So we have f of 4 comma minus 5 plus h. 4. So we are going to put 4 where x is.
16.
So 16 minus 5. Sorry, plus minus 5 plus h minus 1. Right?
Yeah.
Minus the same thing for we have 16 minus 5 minus 1 over 8.
16 will cancel 16.
This is 16.
You don't want to put that.
This is 15. Because of these brackets, so you don't confuse yourself.
Okay.
So let's take it step by step. So we have 15, this minus this is 15. Let's evaluate this. We have 16 minus 1, 15, minus 5, 10 plus h. 10 plus h minus 10, I mean? All over h. This is 1. So this is limit as h goes to 0 of 1. It's still 1. So let's see if we do the same thing, differentiating partially with respect to y, and then plugging in the values, if it will have the same answer. So partial f by partial y is equals to, I'm differentiating with respect to y. So this is 0.
Just 1.
This is 1. At any point is 1. So yes. Yes. At 4 comma minus 5, we have 1. Okay. So the next question, we're just going to differentiate the same way we differentiated here. We're going to differentiate this one here partially with respect to x and y, since we are not given any points.
Yes.
Number 2. Solution number 2. We have that f of x, y is equals to y cos x, y. So what is partial f by partial x. I want you to note that this partial f by partial x can also be written as f subscript x.
Yes.
So this is equal to, I'm differentiating with respect to x, so I'm seeing y as a constant, okay? So I keep my constant, and if I differentiate cos xy, I have minus sine xy. Then I differentiate what is inside. I have just y. So what would this give me? This would be minus y squared sine x y.
Yes.
And then let's do for differentiating with respect to y. So we have products of two functions. So we use product rule. Okay? So we keep this and then differentiate this with respect to y. So this is y. Now differentiate this with respect to have minus sine xy times x plus.
Differentiate.
Now I'm going to keep this and then differentiate
Cos
this.
xy.
Cos xy times 1.
You don't need just cos xy.
This is equals to, I'm not doing it for the u. So this is equals to minus xy sine xy plus cos xy. And that's our answer. So we have gotten partial f by partial x, and we have gotten partial f by partial y, that's f subscript y and f subscript x. And you can see that they are not equal. So differentiating with respect to x does not mean that you will get the same result as differentiating with respect to y. So you must be careful. Thank you for watching this video. See you in my next video. Please subscribe to the channel and like the video. Bye.